Good day everyone, my name is Chong. Today I will present a chapter called Spanning Tree. So redundant topology. Redundant topology, they provide the advantage for eliminate single point of failure. For example, this switch they have a redundant link. Let's say this link is down, they still can use another segment 2 for transmission, but it can cause some error or problem like broadcast storm, multiple frame copies, and MAC address table instability problem. Broadcast frame. So let's say for example the station D, it want to communicate with station A. So initially the switch is not learn any MAC address of the station. The station D have to send an ARP request. The ARP request consists of the broadcast frame broadcast. So when they send the broadcast, the switch receive the broadcast from the E3. They need to forward out to every port except the source port. Broadcast storm. In this example, the host X want to communicate with router Y. So they need to send the ARP request to get the MAC address for the router Y. So the switch will, the PC or the host X will send an ARP request, and this switch A they receive a broadcast from the host X. This switch A they will forward to every port except the source port. So for example, this switch receive the broadcast from here and will forward to every port, and this switch B also will receive the broadcast from the switch A, and they also will forward out to every port except the source port. So it can cause a loop or the broadcast storm. Multiple frame copy. The host X want to communicate with router Y, so they need send a unicast to the router Y. First they send it to switch A. The switch A will directly send to the router Y. At the same time, they also will forward to the switch B. So on the switch B receive, they also will forward to the router Y. So in this case, the router Y will receive 2 copies of the same frame. MAC address instability. The host X communicate with router Y, so they will send to the switch. So switch A they will receive from the port 1. On the switch B, they also will receive from the port 1. So when the switch A receive from the port 1, they will forward up, and the switch B will receive from the switch A from in the port 2. At the same time, the switch A also will receive the same frame from the port 2. So this can cause the incorrect or MAC address instability on both switches. So to solve this loop issue, the IEEE come up with standard called Spanning Tree Protocol. Spanning Tree Protocol is using the IEEE 802.1b. This protocol is used to prevent the looping. They will block one of the port in the redundant link. So this block is not shut down. It will not receive or forward any data. So for spanning tree operation, there are 4 rules. One is 1 root bridge per broadcast domain, 1 root port per non-root switch, 1 designated port per segment, and non-designated port are unused. Means the unused port, they will block the port. STP root bridge selection. For STP, they will select the root bridge based on the lowest bridge ID. The bridge ID is content of the bridge priority and the MAC address. First, they will compare the priority of the switch. If the priority is same, so they will compare the MAC address. These are the states for the spanning tree. For the block port, it converts to forward port. They need to take around 50 seconds. The state is from blocking state and become the listening state. After that, they will become the learning state, and last will come to the forward state. Thank you.